We're looking at the convolution, and then the objective or the aim is we're looking at the inverse of 2 Laplace. Okay, inverse of what? Of f of x, g of x. Okay, and definition is just let f of t and g of t be a piecewise continuous on these interval. The convolution of f of t and g of t denoted by what? F times g is defined as this. Okay, and if you look at this definition, the convolution is denoted by f times this. Okay, as a function of t, and that will be integral from 0 to t. The lower limit is 0, the upper limit is t. Okay, and what we are doing here is just that we are substituting t minus v for the function f. And for the second function, we are substituting v for the second function. And that's that. Okay, under this integration. Let's see application for that. Yeah, find t star times t squared. Okay, so if you want to solve that, very simple. Just apply your formula from 0 to t. Okay, then from the formula, this is your t. Okay, you are substituting what? T minus b. And that will be what? T minus b for t. Okay, you can close it. Then the other function is what? You substitute. Your function is t squared. So you are substituting what? This t squared must be a function of what? A function of b. And that will be what? That will be b squared. That's why I said g of b. So whatever your second function, that means you are plugging in a v into that function. Okay, and that's that, and that will be what? The v. So the next thing to do now is for us to expand this, which means from 0 to t, there will be tv squared minus v cubed the v. Then you now integrate now. Your t is just a constant because you are integrating with respect to v. That will be t v over 3 over 3. Then minus v4 over 4. Then you put your upper boundary and lower boundary. Okay. Then in that case now, anywhere you see v, you put for the upper boundary you have t times your t here, that t3 over 3 minus t4 over 4, that's the upper boundary, then minus the lower boundary. So for lower boundary, everything will become 0. This 0 over 3, so just 0. So our answer will just be t4 over 3 minus t4 over 4. Now that's our answer to that question. Okay. The only thing you can do here is just to take t4 out if you want to. That's 1 over 3, 1 over 3 minus 1 over 4. I can use calculator for that, which will be equal to 4 minus 3. That's 1 over 12. That will be t4 into bracket 1 over 12 if you want to do it in that way. Okay, so that's that on that question. Yeah, we're looking at the properties. Okay, if letter f of t, g of t, and h of t be piecewise continuous on that interval, then f this will give you this. Okay, this is equal to this, and this one also will be equal to just like this one, like a distributive property. So this will be this one with this one plus this one with this one. Okay, so that's that, and this one with this and this is equal to what? The f can go outside, then you can combine these two together. Okay, and if you convolute f with 0, that will be what? That will be 0. So these are the properties. Okay. Yeah, we are looking at theorem. Let f of t and g of t be piecewise continuous on this interval of exponential order alpha and sets. Okay, the Laplace of no, this is the Laplace symbol f of x is something as this. f of g. Okay, that's how we can write your Laplace. This is Laplace of Laplace of f, which you can also write in this form. Okay, and g of s also, this notation is equal to this. Okay, then what we are seeing now is that when you now want to convolute the Laplace of the two functions, okay, asterisk together, multiply together, will give you this symbol and this symbol. They are the same thing. So if you take the inverse of this, of the Laplace of the product of two functions, it will give you what? You know, when you take inverse of a Laplace, it just give you this, this. And that's what we are saying, that inverse of Laplace of two functions will give what? The function there. So let's see applications to that. Yeah, use a convolution theorem to find the inverse of this expression, 1 over x minus a times x minus b. Actually, we can use partial fractions to solve this. Okay, but sometimes it might be complicated. Okay, but we are being told to use convolution to solve this. So when you have this now, we can split this one down. This one will be equal to inverse of 1 over x minus a. Okay, and then times what? Times inverse of 1 over x minus b. Yeah, split down to 2. We just have to note that inverse of 1 over x minus a is EAT, and then inverse of 1 over x minus b is exponential bt. Just we have to note that. Okay, and the question we have here can be written as inverse of 1 over x minus a times 1 over x minus b. Yeah, you can split into two parts like this. Okay, so and that will be equal to what? Inverse of 1 over x minus a times inverse of what? 1 over x minus b. Okay, you can split that into two. Then, since it's a product, since when you have inverse of two functions, then you now have this will now give you this will give you EAT. Okay, you can put your this sign there. Okay, the inverse of what? BT. Okay, so then you're now having F what? F FG, as a function of t. And the formula is what? From 0 to t, f of what? F of t minus v, g of v, dv. So let's use the formula for this. Anyway, you see t, that would be what? T minus v. Okay? Integral from 0 to t. Then followed by the second function is what? That would be what? E what? E b v. Second t would what? The functions of what? Functions of v. Okay? So that's that. So this is your f, this is your g. So turn this one to functions of v. So anywhere you see t there, that will be v. So this is what we have, the v. The v. Okay, that's what we have now. The v. We made there's a mistake here. This a is here. You put your a there, and then open your brackets. Your t is substituted for what? T minus v. Okay, and then you have this. So then we now have E AT dot E minus AV dot E BV dB. Okay. Since this one doesn't have V, you can bring it outside the integration from 0 to t. You can take it outside. That will be equal to, I can combine this one together. That will be equal to what? B minus A V. Okay, positive B minus V dV. And this will be equal to what? EAT. Integrate this. If you integrate this, this is a constant. Integrate this, then we have E B minus A V, then divide by what? Attachment of that V, B over H. And then put your upper limit T 0. Okay. So the integral of exponential is that function, but you must divide by the attachment to that variable, that V, or by derivative of the power, respective V. So, and that will be equal to, this is your constant, AT. You can substitute for the upper and lower limits when T is equal to, so we have E B minus A T all over B minus A, then minus, that will be 1 over B minus A. Then you can close the bracket there. So you now have E AT, you have EAT into bracket times E B minus A T all over B minus A, then minus, allow this one to come in, and that will be equal to what? EAT over B minus A. Okay, allow that this constant to enter that bracket. So we have that. So if you like, we can open this one. We can combine this one together. So it should be equal to. We combine these two together. That will be E. T is common. That will be A plus B minus A. T all over B minus A minus E A T over B minus A. And this will give you, this one will cancel. Then we have E B T over B minus A minus E A T over B minus A. So that's that on that question.